guys, today I have started a new playlist which is on M1. So first let's start with the first chapter and basic introduction. So what I'll be doing is I'll just for the introduction part I'll write complete notes and then I'll just explain it so that these definitions will be useful for you in the exams because they might ask for 2 marks questions or 3 marks questions. So I'll just if there is any like this theoretical part, we'll just go with the written followed by the explanation. If at all the video is about some like, or if we are doing any theorem or any procedure that need to be explained, I'll just go with the video itself. I won't write complete answer previously and then I'll explain it step by step very neatly. Okay, so firstly in this video we'll just complete the matrices introduction. So from the next video onwards we can start the problems and theorems, and also I'll be telling you the problem for every topic, and if you want any particular type of question or if you want any topic to be explained in more detail, please feel free to put that question or put the topic in the comments. I'll be very happy to help you all. And now let's see what is matrices. So what is matrix and what is matrices? So the difference is, for if we are considering only one matrix, we'll call it as matrix. If we are dealing with more than one matrix, we'll say it as matrices. So simply it is a plural form of the matrix. So first let's see what is matrix. So matrix means it is a system of numbers. Okay, it's a system of numbers which can be real or complex numbers, and they are arranged in a rows and columns. Okay, that is called as matrix. So how many rows and how many columns, we don't know that. So there can be any number of rows and any number of columns. So for that case we will denote m rows and n columns. Okay, if we are dealing with some problems, then we can go with 2 rows 3 columns like that. But in a definition should be in such a way that it should satisfy any condition. So in the definition you have to mention m rows and n columns, and this is how you represent matrix. So these are called as rows. Okay, these are called as rows and these are called as columns. Now how you represent this notation in the matrix is m cross n. That means first you have to write how many rows are there, and then you have to write cross symbol, and then you have to write how many columns are there. Okay, here m rows are there, so we have written m first, and n columns are there, we have written n columns here. Okay, now what is the order of matrix? So order of matrix means how many rows and how many rows and columns are there in particular matrix. So it is represented by the order of matrix. That means, for example, so if you consider this in the definition example only, how many rows are there? M rows are there. How many columns are there? N columns are there. So we are representing it as m and n. So if anyone asks you what is the order of matrix and they give this matrix, you have to say m by n. That means you are telling them how many rows are there and how many columns are there. That is what the order of matrix. And for example, if we have 2 rows, 0, 2, okay, some 3 and 2. Now for example, if you have this, what is the order of matrix? 2 rows are there, 2, and how many columns are there? 2 columns. So 2 by 2 matrix. This is how you have to write the order of matrix. And if you see types of matrices, that means we have many types of matrix, and we particularly no question will be in the 7 marks question or 5 marks question, 10 marks question like that. They'll not be asking you what is row matrix, what is column matrix, but we will use the concepts of all these matrices. So just don't ignore this introduction part. It is very much needed to get all these concepts in detail. Okay, so now row matrix means matrix having only one row. That means only one row, like this, 1 2 3, only one row. Columns can be any number of columns. Okay, and now what is column matrix? So column matrix means only one column. That means we should have only one column and we can have any number of rows. Okay, this is the column matrix. And now null matrix. So null matrix means the name itself is telling that the matrix contain null values. So basically null means we'll denote it with as 0. So here null matrix means 0, right? So if all the elements, okay, what are elements means each position digit or number is called element. Then if the numbers, all these elements are zeros, then we say it as a null matrix. Okay, now rectangular matrix. So rectangular, that means the rows and the columns should not be same. See, in square all sides will be same. Okay, in rectangle only two sides will be same, any two sides. So here also same. In square matrix all will be same, that means rows will be same and columns will be same in square matrix. In the rectangular matrix it should not be the case, right? Length is different from the breadth. So here also you have to maintain the same thing. M is not equal to n, that means rows not equal to columns, and this is how you represent the rectangular matrix. And square matrix I have explained you just now. All the rows and columns should be same. And remember the how you denote the matrix is A of ij. A of ij means element. Okay, A of ij is element and A is the matrix name. For every matrix we have to give name. Okay, all these rules we will be understanding more while doing problems. Okay, I'll also explain you how you have to represent the answer or the procedure neatly so that you will get good marks. Okay, and now Aij means element position. Okay, I is position of row, J is position of column. This I'll also explain the sums. Okay, now lower triangular matrix. Lower triangular matrix means the name is saying is lower triangular, but it will be in reverse when we take example. Remember this thing, most of the people will be confusing here. Lower triangular matrix means upper elements should be 0. Okay, above diagonal elements. This is lower triangular matrix. For lower, upper elements will be 0. Upper of what? Upper of diagonal elements. Diagonal means these elements. Okay, and how you have to represent means in the matrix form. There will be no separate notation for this. You have to just like if you get in the exam, you just write this matrix and just circle it like this way, or if you don't do that also, it's fine. Okay, now upper triangular matrix. So I have already mentioned you that for lower, upper elements will be zeros. For upper, lower elements will be zeros. Okay, and I'm not explaining you definition way, I'm just explaining you the concept. So if you are preparing for the exam, just make sure that you read this definition or whatever the concept, you can just put it on your own words also, but this is how you have to write in the definition. Next, triangle matrix. That means a square matrix which is either lower or upper triangular. That means every upper triangular matrix is triangle matrix, every lower triangle matrix is triangle matrix. Okay, this you don't have to know much. Next, principal diagonal matrix is important. Okay, if a square matrix, and also make sure that when you are reading the definition, just observe whether it's a square matrix or matrix. Okay, we have difference. Square matrix means rows and columns should be same. Just matrix means there isn't any condition like that rows and columns should be same or rows and columns should be different. Okay, it can be any of them. So principal diagonal matrix means whatever the elements positions we have each I equal to j. That means diagonal elements. Okay, these elements are called diagonal elements. And I'm underlining the important part. So in a square matrix, the set of aij elements for which I equal to j is called as principal diagonal elements. And I'll explain you I equal to j here only. See, because for example, if I'm writing, I'm saying 1, what you will write? You'll write 1, but the position will be a I j. Okay, here what we are writing? Columns. Here what we are writing? Rows. Okay, now the position is called as I and j. Okay, position we will represent in the form of I and j. Which row here? I'll explain you. In the first we have this. Okay, so if you observe here clearly, I wrote A11, A12, A13, A1n. That means why I am writing only 1 1? If you observe the pattern, first digit is same, 1 1 1 1. Next, the second digit is 1 2 3, so on. That means it is increasing. From this what we can conclude? Their first digit is same, in the sense they are in the same row. That means I is for row, j is for column. Aij, A is the name of matrix or element. Aij represents a particular element in particular place. For example, if I is 2, j is 3, that means 2 3, second row, third element. That is how you have to know I and j. Okay, first I is row, j is column. Okay, and this is about principal diagonal. Principal diagonal means I equal to j. That means A11, A22, I and j should be same. So A11 means this one, A22 means this, A33 means this, A44 again one more row and column, in that way. Okay, and now let's see diagonal matrix. So I have already explained you diagonal elements. We'll see the diagonal matrix. Diagonal matrix means only the diagonal elements are non-zero values and the remaining elements are zeros. Okay, only the diagonal elements are not zeros and the remaining elements are zeros. Okay, next is scalar matrix. Scalar matrix means a diagonal matrix in which diagonal elements are equal. That means, see, in the diagonal matrix only diagonal elements are present, other values are zeros. Here also only diagonal elements are present, other values are zeros, but condition is what? These diagonal elements should be same, 2 2 2. Yes, if it is 3 3 3, but here we can have different numbers. Okay, next, unit or identity matrix. So unit means 1, identity means 1. So if the diagonal elements are 1, then we say it as unit or identity matrix. Now how you represent this? Why I wrote I2, I3? 2 means 2 by 2 matrix, 3 means 3 by 3 matrix, and this representation is only for identity matrix. Okay, I2, I3, I4. And we have trace of matrix. So trace of matrix means sum of diagonal elements. It is called as trace of matrix. That means you have to add the diagonal elements value, whatever it is. Okay, so your diagonal elements are A, E, I. So I have added. So you will get 2 marks question for this. Okay, they'll give matrix and then they'll ask you find the trace of the matrix. then you have to find this way. You have to write the formula and then you have to write the procedure. Next, singular and non-singular matrix. So singular matrix means their determinant is 0. That means det of matrix is 0. So det means this symbol, okay? And how to find the det, and that procedure, you'll have some procedure which will be very short. I'll explain you when we are working on the sums, okay? Because if I explain you here again in the video, if I don't have to explain. So we'll just see the theoretical concept here and I'll explain you the complete procedure in the sums, okay? So det, we'll call it in the short, we'll call it as det A. If det A is 0, then that particular matrix is singular. If not, it is non-singular, okay? Now only non-singular matrices has inverse. This is important point. Why? I will explain you the reason also. For now, remember, I'll explain the reason here. See, how do you find the inverse of a matrix? For every matrix, you will have inverse. So I am telling here for every matrix, but it is not for every, it is for every non-singular matrix. Why? Because we have certain conditions to find the inverse of the matrix. To find the inverse of a matrix, first we need to find the det A. If det A is not equal to 0, only then that particular matrix will have the inverse. If not, it will not have the inverse. Why? Because we will see. This is the formula of inverse, okay? A inverse is equal to adjoint A by det A. Okay, this is how you have to find the matrix. Adjoint A by det A. Adjoint A, det A, how we will find that all we'll see in the problems again. So if you see here, det A means what? This one only, right? If it is 0, then the value of it will be infinity, right? Denominator should not have 0. That is why we will take only the non-singular matrices. How we will classify whether it is singular or non-singular? By finding the det only, right? So these are the conditions you have to check for the inverse of a matrix, and all the theory part which I have explained in this here with the definitions and all, you have to just go through it, because you might get the questions for 2 marks and 3 marks. And if about sums, we'll just go in detail in the coming videos. And please subscribe to my channel, and if you have any doubts, please feel free to put them in the comment section. Okay, thank you.